we're going to make a transition and start to talk about all of those possibilities for putting materials into solution, putting moles of some compound into water mostly times, but you can mix them in other kinds of cases. Matter of fact, I'd like to talk a little bit what some of those terms mean. And first of all is the first term is solution. Solution just means you take two different materials and you mix them intimately so that the molecules become, intimately mixed, one to one, or so that all the particles are being surrounded pretty much. You don't have clumps of the molecules being surrounded. So all the molecules become homogeneous, the same phase as each other. Okay. Most of the time we're talking about water, like in salt, where you can make salty water, or you can make like liquids like soda, which are mixtures of sugar and water and some colorings. And homogeneous just means dispersed evenly, whereas mixture means it's a combination. You can make it sweeter than sometimes others. You can make it less sweet. You can make it saltier. You can make it less salty. So it's not got a fixed ratio like the compounds we talked about before. The thing that does the dissolving is called a solvent, and the key word there is vent. Think of a vent as something that moves materials into it to pull bad air out of a room and vents it. So that's the liquid that does the dissolving. Solute is the thing that gets dissolved. Okay, so just so you hear that. The process of mixing is called solvation. So you're going to dissolve, or you may use the word dissolve. You're going to dissolve something. That is a solvation process. Hydration is using water, and that's the most common substance we're going to use, hydration. So you're going to hydrate the ions that you have, and the challenge is depends on pulling those ions apart, like we talked about in the last unit. Is if these things are both highly charged, like +2, +2, or +3 and +2, water's got a big job to pull those apart. But a lot of times, if there's at least one of them that's a plus or a -1, water can pull them apart. Water likes plus and minus things, but it's got to get an easy, it only has so much tug. So like nitrate, if you look at the nitrate here, that's an easy pull for water to pull apart. The process is that the calcium and the nitrates get pulled apart from each other. Water surrounds the calcium and water surrounds each nitrate. And the way we show that in a chemical equation, like you've seen, is putting the words aqueous behind. This is a solid on this side, and usually they would write it like that. And then the dissolved process shows the ions when they're being surrounded by water. But that's the way you have to think when you see calcium +2 aqueous. It just means surrounded by water. If you took and dried the water out, those ions that are plus and minus would like each other and find each other and reform a solid. Just like if you boil water all the way out of a pan, you'll notice you'll get a white crust at the bottom of the pan. Or if you've been out in the desert, you might see a lot of places that have white in them. The salted sea is a good example. On the shores, you might see a lot of white crust there. Last couple terms, miscible means that they completely dissolve in each other. They completely are mixable. So alcohol and water is a good miscible solution. Two liquids, well, air, all gases are miscible. They completely mix in each other. So nitrogen and oxygen in any ratio can mix. Solubility is how much can dissolve. So miscible means they are completely dissolvable, but what if it can't? Have you ever seen your sugar solution in your honey? There is a point where the honey is a maximum amount of sugar is dissolved, but if you let it sit, some of that will crystallize out at the bottom because it's got, like I said, some of the water evaporate out of there and leaves solid honey in the bottom. So you've reached a solubility. That's as much as possible as can dissolve. Usually that's given as a graph. A lot of times they'll show you as you get warmer, for instance, you can dissolve more and more liquids, solids, you can dissolve more solids. It's interesting, it's the opposite for gases. We'll talk about that a little later. But how much can dissolve is called solubility, and saturated means you've dissolved as much as possible. Supersaturated can occur, especially when you start dissolved and then you let it cool off. Now there's more than it's supposed to. Usually what ends up happening is that if once you get a little bit of dust or some other crystal or some kind of thing that can start the others falling around it, you will start to form that substance will start to come out of solution. Putting a little dust in there may cause a bunch of crystals to fall out. And so that's interesting. What falls out, anytime you get to a place where you've got too much dissolved and it just can't stay dissolved anymore, usually is a solid. Usually they're little particles and they'll look foggy and then it'll become milky and then you can't see through it at all until you give it time to settle down, and those particles will fall out. That's a precipitate. You've seen the words precipitate already. It's a solid that's formed. Now, don't just get confused by solids and liquids like sugar water, okay? There are 3 or 4 other kinds of solutions. Air is a good example. 2 gases mixed together as a solution. A gas in a liquid like soda or beer. Carbonated beverages, they have gas, carbon dioxide dissolved in that liquid. Fish survive on the oxygen dissolved in liquid and water, and so that's a solution. Gases can be dissolved in solids, and a lot of times that's going to happen in these what are called fuel cells. They're trying to get hydrogen to move on inside the surface of some metal, and then they're now available for reacting, and you can drive certain reactions that way. A lot of times catalysts, what happen inside, the gases dissolve a little bit into the surface of the metal, and then they can change easier, but that's usually gas solid, and it's usually done through a catalysis sort of process. Liquid, water and alcohol. Water and antifreeze in your car so that it doesn't boil over. It keeps those. That's a solution. And then the last one is solid. So we've talked a little bit about those, like my jewelry, like a gold ring. Those are two solids that had to be melted first, and then they can mix in a portion. Metals will mix in a portion of solids. So that's the kinds of solutions that we might have. Now, one of the other things I want to mention is that's when the solutions are when the particles are mixed intimately atom by atom. What happens if you have like large particles, thousands if not millions of atoms all kind of surrounded by water? They're still small. Millions of atoms are still small, but it'll be surrounded by water. It'll eventually settle out. That's called a suspension. So if you look at a river water and you can't see through it, it looks cloudy like I was talking about, there's a suspension of materials that are in there. If you look in the ocean water at the shore particularly, there's suspension of materials. Now, what about some substances, like if you get something and you let it sit and it's been there for a week and it's still cloudy? Okay, the particles are getting much, much smaller, maybe only thousands of atoms. They're called colloids. The colloids are interesting because they're usually stable suspension. So if you're a cook and you like lemon meringue, the meringue is a colloid of air in a liquid. A colloid might be like a gel. There you have liquid, suspended, big chunks of liquid that are being surrounded by a cage of solid, like your tennis shoes have gels in them, or your shaving gel, for instance. But when there's only hundreds of atoms, 10 to 1,000 maybe atoms or molecules that are surrounded by water, but they still aren't dissolved. The reason you can tell because they're still cloudy. You can't see through them clearly. When you finally get down to atom being surrounded by the liquid or those other substances, atom by atom kind of solution, you can see right through them. Okay, and that's a solution. So there are some terms that I just want you to get used to in terms of these solutions. I'll give you some problems in terms of this here in a second.